In this video, I'll define a special class of vectors called unit vectors, and then two particular unit vectors that will be of utmost importance, and I'll show you why they're so important. So, as we've seen, we can compute the length of vectors. A special type of vector is one with length 1. So length having a unit length, and so we call these unit vectors. So let's say let me draw real quickly here a Cartesian plane. Here's my Cartesian plane. Let's go 1, 1, negative 1, negative 1. So let's look at some unit vectors here. This would be a unit vector. It has length 1. Let's do a green one, even go in the opposite direction. This is also a unit vector. This is a unit vector. And what am I missing? How about this one? This is a unit vector. But actually anything, if you notice here, this forms, there's a circle here with center at the origin, and radius 1. Those all lie on that. Any vector, let's get another color in here. I'll use this bright pink. Any vector that has tail at the origin and head on the unit circle is a unit vector. So that's another unit vector. Here's another unit vector. Anything, again, with tail at the origin and head on the unit circle has length 1 and is therefore a unit vector. So what's special about these? Well, actually, these are going to help us talk about the direction of other vectors. We can reference a unit vector in that same direction. We'll get to that a little bit more in a second, or in the next video rather. In this one I just want to talk about these unit vectors, and in particular the special ones. So this blue one I drew here, 1, 0, right? It goes over 1 and up 0. That's a special unit vector. We call this vector I, or I with a hat. Sometimes I'll put a hat on it or try and boldface it, so maybe I'll put a hat on these. I and J are these special vectors, J being just going up 1, 0, 1. And I mentioned this in a previous video, why these are such special vectors. It's because I can write any other vector in the plane as a linear combination of I and J. Let's see how that works. So let's take, for example, the vector 3, 4. So that goes 1, 2, 3, 1, 2, 3, 4. Point 3, 4. Here's the vector 3, 4. Well, I have my two coordinate unit vectors here. This is I, and this I'll use green, and I'll use red. And here is the vector J. Those are my two special vectors I defined on the last one. And remember back to that example we did a few videos ago, I can write this vector 3, 4 as a combination of I and J. Vector 3, 4 goes over 3, I, and up 4, J. Right, so this vector here then would be 3I, and up like this. Oops, maybe red for that. Right, go 1, 2, 3, 4. This would be 4J. And so 3, 4 is 3I plus 4J. So really not a whole lot going on here in terms of actually calculating. So negative 2, 1 is, you guessed it, it's negative 2I plus J. It's not too hard to actually take these position vectors when I have them as position vectors and write them as linear combinations of these two unit coordinate vectors, minus 2J. Could write it like that. All right, so not too hard to go from here to here. What's really going on here, the important thing, is that I'm writing a vector in terms of two special vectors, this I and this J, and no matter what vector I give you in the plane, you can do this. You can write it as a linear combination of these two other vectors. These are called basis vectors. Again, we call them unit coordinate vectors, I and j. So this is actually a rather important thing for a vector space to have, and yeah, we'll see this coming up a lot in this class. So where are we going from here? As I mentioned, these unit vectors are also going to be a way for us to talk about the direction of other vectors. And so we'll get to that in the next video. I'll see you there.